and welcome to C International School Science Adora, where you can find amazing information about science and also experiments. So this is PremKrishna K of C International School, studying in 9th standard, and today I'm going to demonstrate some of the experiments of chemistry. Experiment number 1. Have you guys ever heard of hot ice? Well, maybe not. So hot ice is really opposite to cold ice. It forms crystallization. Crystallization occurs in this experiment due to an exothermic reaction. Hot ice, it forms with the help of sodium acetate trihydrate. Yes, with the supersaturated solution is which hot ice is formed. So let's see how to do the experiment. So for this experiment, you'll need vinegar and baking soda. That's it. So for this experiment, as you can see, I have taken a bowl and now I'm pouring vinegar in it, and I've poured all the vinegar, and now I'm going to add nearly 1 tablespoon of baking soda. So as you can see, there's a reaction occurring. So now as you can see that baking soda and vinegar are reacting to each other. So now after this I'm going to keep the bowl, so I'm going to boil the solution. So I'm going to make it super saturated, as I said. While this process, they will also form tiny crystals. So these crystals also we should scrape and keep it for the experiment. You can see tiny crystals over there, white color. So these are the crystallized sodium acetate trihydrate. Yes, and these crystals are which will help us to crystallize which will help in our experiment of crystallization. So before that, see that you will keep your so you will keep your solution, that is the sodium acetate trihydrate, which you boiled just now, in a cold temperature. You should cool down it, as it will be super hot. You have to cool down it. So I'm going to dip my finger. So there you go. So as you can see, it's freezing. So have you people ever heard of a matchstick getting attracted to the magnet? No, right? So now I'm going to prove it. So for this experiment, you will need a matchbox and a magnet. That's it. So now, as you can see, there are 2 matchsticks. And now I will bring the matchstick, one of the matchstick, near to the magnet. So I will break the head of the matchstick and bring it to the magnet. So as it is an unburnt matchstick, it's not getting attracted to the magnet. So now you people might be thinking that will an burnt matchstick gets attracted to the magnet? Really? I'll prove it now. So as you can see, it's burning. And now I'll break the head of the matchstick. So I have kept it on the plate, and now I'm bringing the magnet to the matchstick, near to the matchstick. Hey, how did this happen? Oh. So how does this happen? So this happens because when you burn things, you're oxidizing them, not reducing them, right? Of course, it's more complex than that. So matchstick heads contain iron oxide as a colorant. The reduction of iron oxide to iron involves many reactions, especially in the case with matchsticks, where wood, paraffin and and different chemicals are involved. So, when the matchstick is burnt, it undergoes a chemical reaction, turning the red head into iron. The iron produced is what causes the matchstick head to attract to the magnet.